Okay, well, it's been a while. I have been busy, as they say. Where the hell am I? We're talking template string. Okay, yeah, we got that one. And then the next one, still template string. Okay, wait. So print substitute, then code, then S template, a thingify subscription cost, blah 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 blah. Okay, we're okay there. What's the next one? Concat strings. Yep, we got to that one there. And then still all concat join. Yeah. Okay, and do we get to joke functions? No. Okay. So once again, the lay flat book does not lay flat. So note on string concatenation. Up to this point, we've been using an addition operator to put them together. It's acceptable and basic, however, seldom the most efficient when combining. Therefore, we prefer the join method or string literal. Okay, concat strings. Hello. Yes. Yeah. Oh, geez. Okay. No, we're on functions. What are we doing? Okay. We need to change directory to chapter 3. And now that we're in here, we can hit code. Joke function .py. Okay. Now we're going to create a function called def del joke, and then we're going to put in joke type. So that's the start of the function. This is a lot faster than CS50. Jeez. Declare the function with the def keyword followed by the name of the function. The parameters are named in parentheses after the function. The entire header is concluded with a colon. Below the header, indented one level, is the suite or body of the function. So, which is going to be this whole thing. So, if joke type exclusively equals funny, we're gonna print how can you tell if an elephant is in your fridge? Oh yeah, it puts all of that stuff there. Print there are footprints in the butter. Sure, buddy. As they say. Else if a joke type equals lethal. Oh, I can't wait to hear this stupid one. We are going to print I have no idea what this is. I'm sure this is funny to a German person. And finally, else. Else, why did the chicken? Cross the road. To get to the other side. Okay, so you call functions most ways the same. Okay, so then that means that we come back down to here and we're outside of the function, and then we just say tell joke funny. Right? And then we can hit control grave, put the spec up there, and then we can go. Python. Joke function dot py. Okay. Okay. Sure. Sure. Classes and objects. I go into defs and functions, and there are many cousins in chapter 6. Oh, fuck. Great. Python fully supports object-oriented programming. Object-oriented programming. In fact, one of the language's design principles is everything is an object, or at least behind the scenes. There's a lot more classes than meets the eye, but for now, you should just get absolute bare bones familiarity with the syntax. The following class contains a joke of a selected type and displays it on demand. Okay, so now we're still here, and we will start with code joke underscore class UI gives us a new thing, so now it's going to be called class joke. I define the class using the class keyword and the name of the class and a colon at the end of the header. This is followed by the suite of the class indented one level. Okay, so it's going to be def space dunder dunder init joke underscore type. So we're defining another function called it starts off with dunder dunder or underscore underscore initialize underscore underscore, and Harvard said that it always has to be able to initialize itself. That's why you put self, and then any sort of variable you need you put in as the joke type. So we go if joke type, if joke type equals, is this the same shit? Okay, perfect. So we go back to here because I'm not rewriting the world. We're gonna copy this, come back over to here. We have a different else statement. Oh, okay. Okay, so we have self dot question equals so we need to go back here. Okay. So first things first, we're going to fix this. We're going to hit Command F, and we are going to find everywhere that it says print. And now, match whole word. We're going to replace it with self.question. Right, and then we'll just have to go back and switch out for so this guy is going to turn into answer. Okay, so I think we have an indenting issue here. Okay, so that takes care of that indenting issue question, else, okay. Now the initializer, which is similar in purpose to the constructor and others, same method named and at least one parameter called self. we can go back to here. We can hit def tell self. Print dot. Oh. Self. Question. Self dot answer. Okay, functions belong to class called method. Okay, and now we're out of all of it, and then we want lethal joke is equal to joke dot lethal, and we want lethal underscore joke dot tell. Okay, so we create a new instance of joke by passing the string lethal to the initializer, the init from earlier. The new function is stored in the variable lethal joke. Then when you use the dot operator to call the function tell within the object, take note that you don't have to pass any argument for self. That's done automatically. Okay, so this should now work. So we come back to here and we type in Python joke class. Joke class dot py. Tell. What line is this? Line 12. We forgot a colon. Yes, we did. Okay. And now even more errors. Okay, so we have a problem on line 15. The error comes up at line 15. Okay. Your joke has no attribute called question. Okay. So we went through. Oh, this is all wrong. That's. So we're setting the variable of self.answer So we're setting the variables. Okay, yeah. So yeah, we're setting the variables to equal the string, and then what's going on here? There are there are there are footprints in the butter. Okay, yeah, I see what it did there. Okay, so now let's give this another shot. There. All right. That works. My terminal is being all sorts of stupid. Okay. Error handling. Well, we just kind of did that ourselves there. Python offers error and exception handling functionality through the try compound statement. For example, if I wanted to get a number from a user, I couldn't reliably predict they would type it in correctly. Yeah. Excuse me. You can use an error handling like a different action. Okay. Well, now we're doing another one, and it's going to be code. Try except .py. So we need a number from a user, which is going to be equal to their input class, because this is what it is. Enter a number. Oh yeah, we're okay for time. I've only got like 20 minutes left. Or I take a few second break. I gotta put the lawnmower back. Yes, Lucy. You are a beautiful kitty. I know. Accept value error. And then we're going to set what the value error is going to say. You didn't a valid number. Oh, a valid number. Num equals 0. We're going to print an F string. And then we're going to say your number squared is num to the exponent 2. This is all inline stuff. So then, yeah. Oh, tuples and lists. Okay, I don't want to learn this. So let's quickly run this. Oh, not cool. Python. Try py. Huh. Oh, that doesn't exist. I haven't saved it yet. Bam, now it exists. Enter a number. 5. So that should come out to be 25. Your number here is 25. Okay, perfect. All right, I'll be back in just a second. I'm going to take care of the lawnmower. There's nobody watching, so it doesn't really matter. Oh, shit. Part 2. Ugh. You have to change the name of that. Fuck. Part 3. Okay. Alright, I'll back up the lawnmower taken care of real quick. Tuples and lists. Two of Python are common built-in data structures called collections or tuples and lists. Lists consist of mostly array-like collections in Python. On CPython, there. What? I don't know what CPython is. For example, here's a list of strings with names of cheeses. Yeah, okay. No cheeses for us, Mises. No idea what any of these things are. I don't eat cheese. Red Lichester. Tilsit. Philly. Belpiz cheese. Ooh. Okay, you can close in so there's parentheses, braces, these are brackets. So you close them in brackets. Then we're going to print cheeses on position 1, which is going to be Tilsit, because we start at position 0. Now, if we type this, we're overwriting so now we're going to overwrite it. Right, because we could also just say print cheeses there, and then print cheeses there, and then when we come over to here and we go Python dot cheese list dot py, we should get an error. Oh. Okay, and yeah, we got an error because we didn't put it in correctly. We hit that. So now we get it printing off our list with Tilsit, and then it's printing off our list again when we reset it. When we reset Tilsit to cheddar. Tuple is somewhat similar, but there are key differences. First, Tuple cannot have items added, reassigned, or removed after it's created. Attempting to modify the contents of a tuple with bracket notation will result in a type error. This is because tuples, unlike lists, are immutable, yet you cannot change them. Effectively meaning they cannot be modified. Here's an example of a tuple. Okay, so now with tuples, what are we doing here? Answers are equal to parentheses. Sir Lance Elot. Yeah, to seek the Holy Grail. What is your favorite color? Blue. Hope you guys have actually seen the movie. And we're going to ask it to print answers at 0. And then if we try to do answers 0 is equal to King Arthur, we should get a type error. So let's give this a shot. How about I spell things correctly? Okay, we got our... So, we got it to say Lancelot, which is what we wanted. And then we got our type error, which is also what we wanted. Okay, and now we're going to clear this again. And now we go to loops. While n is less than 10, n add n, and then we're going to add 1 to n, and this is a simple one. If you screw it up, you can hit Control C, because otherwise it'll just, if you don't have this stopper at less than 10, it'll just keep going. With a condition test, finish the header colon. As long as it evaluates the true, this is particularly useful when you don't know how many iterations of the loop will take place before the condition is met. You can manually control the loop using two keywords, continue. The continue keyword abandons the current current iteration and jumps to the next one. The break keyword exits the loop altogether. One common scenario is you may use these keywords in an infinite loop used for running a game or a user interface. So here is a very simple command prompt. Oh, okay, so we're doing something new again. Code. Loop control pi. God, I misspelled it. Okay. While true and input. Enter command. If command is equal to exit, we are going to break. Else if command is equal to sing, print la. And then continue. And if it is not true, we are just going to print command unknown. Okay. Loop control.py. Make sure I do it incorrect. Wait, what? Oh, I didn't save it. Thought I had saved it. Okay. Well, the loop is true is inherently infinite. True is always true. That is the behavior I actually want here. Since I want to keep iterating until the user enters the string exit, at which point I manually end the loop in the break. By the way, if you've been waiting for a do-while loop, this is effectively the way to create the behavior. Okay. Command sing has a different behavior, after which I want to immediately go to the top of the prompt and ask for another command. Skipping the last part of the statement. The continue keyword does exactly that, immediately abandoning current iteration, jumping back to the top of the loop. Okay. Python's for loop is a little different from loops in many languages. It is generally used for iterating over a range or another collection. Okay, so a range or a list or a dictionary or a tuple. Okay. Okay. Print I. We were expecting a colon and we did not have it. Yeah, okay, that's the same thing as before. Starting loop with a header, technically it's kind of a for in loop or for each loop, meaning the loop iterates at the range to start the value of 1 and end before 11. The local variable I will refer and finally. Okay. Structural pattern matching. What the heck is this? For many years, developers coming to Python from languages like C, Java, C++, and JavaScript would ask if there is a Python equivalent to the switch case statement or the match case in Scala or the case when in Ruby and so on. They would always be disappointing to hear a resounding no. Python only had conditional statements. At long last, in Python 3.10, we gained structural pattern matching. Okay. In the most basic use case, you can check a variable against different possible values, and these are literal bounds. For example, perhaps I want to display different messages depending on a user input based on a lunch order. Okay, well, let's code pattern match.py. Pattern match.py, and then we're going to just hit the save so it's in there. Now we've got to have a lunch order, which is equal to an input of what you want for lunch. So we're going to do a match. Match lunch order. I'm going to say case. So if it is pizza, we want to print pizza time. And if it is sandwich, we want to print here's your sandwich. And then it's control down. No. Yeah. That's taco blank. Taco. Taco. this is a bit much here, but taco, 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 taco. 3 tacos. He's switching back and forth a lot. Yummy. Okay, the value of luncher is compared to each case until it matches one. Once a match is found, the case of sweet is run in the match statement. So if the user inputs pizza, the pizza time taco. Underscore is a wild card which will match any value. This serves as a fallback case, and it must come last, as it will match anything. Okay. So a pedantic note. Despite their superficial similarity, match statements are not the same as a C or a C++ switch statement. Python's match statements do not have jump tables. What? And they therefore have none of the potential performance gains of a switch. But don't feel too disappointed, as this also means they are not limited to working with integer types. Okay. Or patterns. Let's give it a test, and then let's make sure I got it right. I forgot a space, but that's fine. Pizza. Oh, I capitalized letter. Yeah. There's a lot of things that would need to be done in order to get this to work correctly. I think that would fix that problem. No, it would not. No, it would not. We don't want to do it there. It would have to be done here. Dot lower. Dot strip. Alright. So when we come back to here, we can hit Python pattern match. What do you want for lunch? And we should be able to type in pizza and get pizza time. And then we hit this again, put a space in front, put a space in the back, and we should still get pizza time. So yeah, there's a lot of things that need to get done to make sure that this is correct. Or patterns. Okay. Okay, so we're still in this one. So let's copy all of this, and then we'll quickly take it all out. We'll bring it back down to here, because there's a bunch. They've changed a bunch of stuff here. So we're leaving the yummy in. So we're gonna have a case called taco. Oh, yeah. So we still have this. Now we have a new case called salad. Or soup. Right, because eating healthy, right, because if we go back to that pipe, if we go back to the land of Tomorrowland, yeah. Dumbass brain. Raw strings, formatted strings. If we go back, we can find the OR statement. Oh, yeah. It's on page 47. You find the OR statement, yeah. Okay. Oh, we're almost to the point where it actually like stays down. Okay. And now we're doing it again. I guess when he's saying snip, he's talking about like salad and all that stuff is still in there. All the other stuff is in there. Okay, so one particularly helpful feature of a structural pattern is matching the ability to capture part or all the subject. For example, it isn't very helpful in our example. The fallback case only says yummy. Instead, I'd like it to have a default message announcing the user selection. To do that, I write a capture pattern like this. Okay, so now we're saying order F string, enjoy your order. But we haven't called for an order yet. Okay, so this pattern this pattern acts like a wildcard, except the value of lunch order is captured as order. Now, no matter what the user enters, if it doesn't match any of the previous patterns, the value will be captured and displayed in the message here. Capture patterns don't just have to capture the entire value. For example, I can write a pattern that matches a tuple or a list, a sequence, and then it captures only part of that sequence. Okay, whoa. Okay, all right. Let's enjoy the process here. Okay, so here, this is supposed to work. So if I say hot dog, it comes back as enjoy your hot dog. Okay. All right. All right. I have to trust the process. Okay. And now we come back to here. We'll copy. Paste. And then okay, so now we have another thing here that says if in lunch order is equal to lunch order dot split max split is equal to 1. And we're going to add a new case. Flavor ice cream print very grown up flavored lunch. In this version, the lunch order has a space. I split the string into 2 parts, which are stored in a list. Then, if the second item in the sequence has the value of ice cream, the first part is captured as flavor, thus the code can account for Bojan if he decides to break down and have strawberry ice cream for lunch. I'm not stopping him. The capture pattern featured has one surprising downside. All unqualified names in the patterns, that is, bare visible names with no dots, will be used to capture. This means if you want to use value assigned to some variable, it must be qualified, meaning you must access it within some class or module with the dot operator. Okay, so if we go back to here and we type in this, and then we go, as he says, strawberry ice cream. Okay, I can only assume that that's what he's trying to say and pop out. Okay. So we're now coming back full circle. We now have a class called special. Which is going to have a variable called today equals pasta cake. And then go back down to match lunch order. if we go to case special dot today, we are going to print today's special is awesome. Okay. Yay, it worked. I didn't fuck it up. Scroll this down a bit. Okay. Oops. No, that's not what I want to do. When I copy, now I don't want to do that. I don't want to go down here. Go to here. Okay. So now we're at guard statement. Where are we? Oh, we're on the last page of chapter 3. Wow, this is great, guys. Yeah, only been in about an hour. Okay. One circle demonstrate which pattern matching is the guard statement. An additional conditional statement that must be satisfied for a pattern to match. For example, the current version of my lunch order example using the logic to split the order by spaces, meaning the code doesn't behave very nicely with other foods with spaces in them. Also, if I enter Rocky Road ice cream, it won't match the current ice cream pattern. Instead of splitting my string by spaces, I can write a pattern guard statement that looks for the words ice cream in the lunch order. And the pattern here captures. Okay, where are we? Okay, so eating healthy today. So right after soup and salad, we're gonna type in case ice cream if ice cream in ice cream flavor is equal to ice cream dot replace dot strip we are replacing ice cream with a space. And then we're going to print here's your very grown up flavor lunch. I do know that that's not the right color because I am missing the F here. So that should take care of that problem. Okay, let's try this again. So let's try what they say. Rocky Road ice cream. Enjoy your Rocky Road ice cream. Why? I don't think that that is correct. Okay, so the pattern here captures the value as ice cream, but only if the guard statement if ice cream in ice cream is satisfied. In that case, I will use the replace to remove the words ice cream from the captured values, leaving one with only the name of the flavor. Then I will use the strip to remove any leading or see. No. Is it because of this? Oh, okay. My prettier is just switching that all over. So, case of ice cream if ice cream in ice cream. Oh. Okay. All right. More about structural pattern matching. There are quite a few other tricks and techniques that work with structural. Chapter 7 with dictionaries by mapping 9. Oh, they work with objects. Chapter 7, dictionaries via mapping patterns. Chapter 9, even by supporting nesting patterns with other patterns. As with many Python techniques, the pattern matching feels like magic. There is strong temptation to use it everywhere possible. Resist this urge. Structural pattern matching is very useful for checking a single subject and its multiple possible patterns. But as you can see from ice cream situation, the lunch order quickly reaches its limits as possible values of the subject get more elaborate. As a rule, if you're unsure whether you need a structural pattern matching in particular situations, stick with conditional statements. To learn more, read PEP 636. It serves as the official tutorial. Wrapping up, you should now have a feeling for Python's syntax and basic familiarity with its key structures. If you were to stop here, you could probably write Python code that at least works. In fact, many developers new to the language do indeed work with about this much information implicitly, bringing habits and practices of whatever language they know best. There's a profound difference between valid code and idiomatic Python code. Writing the latter is the focus of the book. Alright, so that's chapter 3 all done. And the book is finally sort of going to lay flat. Well, I guess that means that I move on to chapter number 4 next time. Which won't be until, hopefully, I don't know when it'll be. It's going to be a while. Project directory structures? What the? Oh. What are we talking about here? Project structure and imports. Oh. Setting up a repository. Okay, well. That'll be helpful. For everybody. Okay. Well, thanks everybody. I know it wasn't a long one, but I hope it worked out for you.
See you all again next time.